Hi guys, in this lecture we want to prove why the square root of 3 is irrational. Okay, so maybe we first start by understanding what is the rational number. If you don't know, I just remind you. So a number m is rational if you can write this number this way: p over q. P is a whole number, q is a natural number, and we want to have a uniqueness, so there is only one way in writing this number. We want to have a GCD, the greatest common divisor of P and Q, should be equal to 1. Alright? So, why exactly square root of 3? Okay, I proved square root of 2 in German. You can check it on my site. And right now we want to ask ourselves, what about square root of 3? Alright, we're going to prove it by contradiction, but at the same time we still need a bit of preparation. The same result as in square rooting of 2. We are not able to prove it immediately, otherwise you won't be able to understand it. So we started with the preparation, and we divide all the numbers, all the whole numbers, in 3 parts. So the first one are the numbers that are multiple of 3. For example, 3, 6, 9, 0 also, 12, minus 3, and all that stuff. So these are the numbers, they are multiple of 3. It means if you divide this number by 3, you have no remainder. Alright? So 3 over 3 gives you 1. Or 0 over 3 gives you 0, no remainder. 12 over 3 gives you 4, no remainder, and all that stuff. Okay, so I can write every single number on this list as 3 times k. Alright, so a number is divisible by 3 if I can write this number as 3 times k for some k, an integer. Alright, the second part are the numbers such that if you divide by 3, you have a remainder equals to 1. Okay, so for example 4, 1, 7, 10, and so on. So an infinite list. How can I write this number? So first of all, 4 over 3 is 1 plus a third, right? And this third contains of 1 in the numerator, which is the remainder. Okay, so the same stuff with 7. 7 over 3 gives you 2 plus a third, and all this stuff. So always the remainder is 1. Okay, and these numbers I can write them as, let's say, b equals to 3 times some s plus 1. So not a multiple of 3 anymore, the remainder is 1. Okay, and the third part, these are the numbers not divisible by 3 with a remainder of 2. So for example 5, 8, 11, and so on. Okay, it's clear. So you divide 5 by 3, you get 1 plus 2 thirds, so 2 is the remainder, and the same result, you divide 11 by 3, you get 3 plus 2 thirds, and all that stuff. Okay, so the remainder is always 2. You can see it, it's clear. So every single number on this list can be written as, let's say, c equals to 3 times some t plus 2. Okay, so what do we need this? Why do we need this preparation for? We want to understand what will happen if we square a, b, and c. This is what we do on the next page. We square a, we square b, and we square c. Right? So if you have a, which is 3k, and you square it, so you have 3k squared, which is 9k squared, which can be written as 3 times 3k squared, which is 3 times something. That means that a squared is divisible by 3 also, which is fine. It was the first squaring. The second, we had b equals to 3 times s plus 1. if I square b right now, 3 times s plus 1 squared, and use the binomial formulas, we proved it also before, we have 9s squared plus 6s plus 1, which I can write as 3 times 3s squared plus 2s plus 1. So this is 3 times something, so this number, exactly this one, is divisible by 3. By adding plus 1 to this number, we are not divisible by 3 anymore. So b squared, b itself is not a multiple of 3, it's not divisible by 3, so b squared isn't either divisible by 3. It's clear. So we proved it right here. And the last part is we have c equals to 3 times t plus 2, and we want to square it also, so we have 3 times t plus 2 squared. We use once again the binomial formulas. We have 9t squared, we have 12t, and we have 4, which I can write as 9t squared plus 12t plus 3 plus 1. Now we're gonna see why I'm doing this. So I can take 3 out. I have 3t squared plus 4t and plus 1 in the bracket, and I have plus 1 remaining. So once again, the brackets times 3 would give me a number which is a multiple of 3, and by adding plus 1 I'm having a number which is not divisible by 3. Okay, so that means once again we had 3 cases. A was divisible by 3, the square number a squared is also divisible by 3. In all the others, so in the second and in the third cases, we had results such that b squared is not divisible by 3 with b together, and c squared either. So that means the conclusion is a is a multiple of 3, let's say 3 times some t. A squared is a multiple of 3 times some b, right? And if a squared is 3 times some s, that means a itself must be a multiple of 3. There is no other way, as you can see on the left side.